right. There we go. All right, this is a continuation from yesterday, and what I'm trying to do is build a Franken-Fabric. And I had some trouble yesterday with, I was really trying to do CRPD, which is Juniper's containerized instance of Junos, kind of. It runs on top of Linux, and it's got some Junos features, but doesn't really have all of them. And there were some weird licensing issues, which I kind of solved, but it still didn't do what I needed it to do. So what I did is I changed it around. So this will be topology 3. And if this works out, I'm going to publish the topology in the configs. And so I made the spines both containerized EOS. I also managed to do IPN numbered for the interfaces and OSPF. And I've got that already working. So so leaf 1 is containerized EOS. Leaf 2 is actually NXOS. So it's 9 kV. And leaf 3 is Junos, but it's I'm using vJunos switch. So vJunos switch. I didn't want to do it this way, and the reason I didn't want to do it is because both Nexus 9K V and vJunos switch, excuse me, use our virtual machines, and they're not containers, so they're much, much heavier. So if we go into the system, so even these 1, 2, 3, 4, 5, 6, 7, and only 2 of them are virtual machines, it still eats up all the RAM. So in fact, the virtual machine, I had to up it to 32 gigs of RAM, and it's eaten up just about every bit of it. So if we do sudo docker stats, we can see here that the leaf 2 is NXOS, and it's taking up 9 gigs of RAM for just one instance. And but it's using up less CPU, and vSwitch, Junos vSwitch, is using up 5 gigs of RAM and eating up a ton of CPU. The rest of them are containerized EOS, and they're using up very little CPU and about 1 gig of RAM apiece. So that's the issue there. So it's one of those things where running containers versus running virtual machines is like it makes a pretty big difference in what I could do. So my hypervisor, I could do up to 96 gigs of RAM, but I'm going to leave this to 32 gigs for now. I think this is enough at least to demonstrate it. So what I do have configured right now is I've got the underlay going, which is OSPF. So let's go into... I'm going to open up a different window here. Open folder. Yeah, there we go. So I'll call this mix, and then you can see my mix container lab topology. The spines, I just made it simple because I want to test out some of the VTEP capabilities of these NOSes. And so the spines don't really do much except route between the leaves. So I just made them containerized EOS because they're so lightweight. Leaf 1, Leaf 2, and Leaf 3. Leaf 1 is EOS. Leaf 2 is Nexus 9K V. And then Leaf 3 is vJunos switch. And the hosts are both Junos, are both Arista CEOS because they're very small. So they're all connected to each other. So that's topology 3 right now. So this is the Franken-Fabric. And I just wanted to see what's it like building a fabric with multiple vendors. And I can tell you right now, I would not want to do this in production. mostly because of the commands are so different on each one, even between NXOS and EOS, which they both have the same similar syntax, but they're different enough that I'm having a hard time going back and forth between them. Let's do a terminal here. All right, so yeah, I've already got a bunch of these in here. So if I do show BGP EVPN summary, I do have EVPN peering going with leaf 3, which is the Junos system. So let's go into leaf 3, admin at leaf 3. Admin at 123 is the password. Show config display set. So I'm running OSPF as the underlay, and I chose OSPF because it's the simplest. There's very little configuration involved on any of the platforms, and that's the easiest way to get the loopbacks into the routing table. So if I do show OSPF or show route, you can see the /32s, 10.1.255. Those are the loopbacks. So we're doing loopback zeros here. And that's going to be what we use for the peering, for the EVPN peering, what we call the overlay. And I did have some cost issues or some metrics. So they don't all default to the same cost for the interfaces. And I think because they're simulating different types of interfaces. So I just set the cost to 10 and then everything equalized out. So that was kind of an interesting thing. The other thing that I ran into is I had to run this command right here, interface unnumbered hello mass transmit 000. Because apparently Arista does not follow the RFC for how it does the broadcast or multicast for OSPF version 2 for IPN numbered. So I did IPN numbered because it's just simpler to do. If I didn't do IPN numbered, I wouldn't have to run this command. Forget who. It was someone on the packet pusher Slack that pointed me in that direction. Hold on. Sorry. All right. So next up, let's get. We'll do leaf 1 because I know I can do that one. That one is easy because that is. We'll do this for BGP for the EVPN overlay. So we don't have any of that configured. So we'll do config mode. Router ID. Router BGP 65.101. Router ID is going to be loopback 0. No BGP, IPv defaults, IPv4 unicast. This just tells BGP that we're not going to route IPv4 unless we specifically say we are, and we're not. Because the IPv4 routing is done by OSPF. We're going to be exchanging EVPN routes with the spines. So we need to set those. So let's do neighbor EVPN peer group. Update source is going to be loopback 0 because we're going to peer loopback 0 to loopback 0. eBGP multi-hop, because when you one of the interesting consequences of us peering in this way is that it's going from a loopback to a loopback, and it's eBGP. So eBGP sets the TTL to 1. So because it's multiple hops, it's going from the loopback to the physical interface to the other physical interface to the loopback. If you set the TTL to 0, it won't make it. The packet won't make it. So we have to do that. Send community. There might be a similar command that we need to do on Junos, but on Juniper, but we'll cross that bridge when we come to it. We just want to get the peers established. And then, so that's it there. And then neighbor EVPN 10.1, 255.101, remote. Oh yeah, 101. Oh, 10.1, 255.101, peer group EVPN. Can I do remote AS here? No, I don't think I can. Yeah. 102. Remote AS is 65001. That's the spines. Okay. And then address family EVPN. Neighbor EVPN activate. Show BGP summary. So we're established. That's what we want, is established. So I've got Junos established. I've got with both the spines. I've got leaf 1, which is CEOS. Now we go to leaf 2. And this is Nexus and Nexus 9K. I used to work a lot with Nexus, but I haven't in a while. But it's all coming back. Show run. So configure mode, is it feature EVPN? Nope. Feature set. Nope. All right. What do we have configured? We do have the routes. So we can get to the loopbacks of the other leafs via those. So those we get those from OSPF, which is good. So now we need to do router BGP 65102. IP router BGP. Feature BGP, and then feature BGP EVPN. Nope. Feature L2 EVPN. 65102. Router ID 10.1.255.2. And then I'm going to have to look up no BGP. What are the commands? So this is where it helps to know the fundamentals of a given protocol. So I know what I need to do. I just don't know how to do it, which is way better than the other way. You know the commands to type, but you don't know what they do. So it's much better to be this way. So what I need to do is whenever you're building an EVPN fabric, there's a couple of things you need to do. And and I like to, if I'm going to lab or if I'm going to troubleshoot, I like to do them in order. So EVPN VXLAN checklist. Number 1, you need a topology, typically leaf spine. Number 2 is you need the underlay. And that's just to get the loopbacks connected. Loopback IP connectivity. Every loopback should be able to ping every loopback. I should see the loopbacks in the routing tables of each of the nodes. A node would be a leaf or a spine. And we've got the underlay is already complete. And then we need the overlay. And that's EVPN peering between leaves and spines. So when we start to generate these EVPN routes, they will get generated on the node, on the leaf, and then they will propagate to the spines, and the spines will propagate them to the other devices, to the other leaves. So we need to get that going. So that's what I'm working on now. The only one we're missing at this point is Cisco. And I'm trying to remember how to configure this, and I don't know that I did a whole lot of Cisco. So I'm looking at some configuration guides. Like here. Don't want to put this in a different screen. So this is, you know, how I do it. I just look at config guides. Sometimes I look at blog posts. And the different vendors will have you do things in different orders. Like this one is having me, wants me to set up the data plane first. I'm setting up the control plane first. Okay, so do neighbor 10.1, 255.101, remote AS 65.1. Do we do peer groups here? Maybe not. Remote AS. All right. We'll do address family L2 VPN, EVPN. Maybe the feature L2, feature set. What am I missing here? Feature VN segment, maybe. Sometimes the commands won't work unless you do enable the feature. And I always forget that because we don't do that in EOS. Again, my most recent most of my experience recently has been in EOS. So where's my, all right, so neighbor 10.1, 255.101. So I'm going to do update source loopback 0. All right. Address family L2 VPN, EVPN. Doesn't like that. I'm be real annoyed if I can't configure this. And part of the reason why I'm doing this is to see what's available to people that are trying to learn this kind of stuff. And it's inconsistent. Am I looking on? So that's release 10. This is 9. So maybe I need to do 9.3. Yeah, we're on 9.3. So I'm just Googling it. Going for the papers, configuration guide. Look up feature. Feature BGP. Feature NV overlay EVPN. NV overlay. Okay, that's, I think I already did that. Neighbor. I don't need that. This is using BGP as the underlay. We already did that. Neighbor's already set up. Yeah, so that's router BGP 65102 address family L2 EVPN EVPN. Yeah, it just won't take that command. Enable, yeah, okay. Feature BGP, NV overlay EVPN. NV overlay EVPN. All right, maybe that was it. All right, that worked. Okay, so neighbor 255 101. And then neighbor 10.1 255 102 remote. Yeah, 65,000 update source loopback 0 address family L2 EVPN. All right, so that worked. We're not doing route reflectors. Show BGP summary. Yeah, so what's the show command to verify? So there's the configuration commands and the show commands. Again, I know what I need. I need to see if the EVPN address family has established with the peers, because I don't know if I need to do an activate statement. These config guides are kind of all over the place. Don't need that. Show NVMe peers. Those are VTEPs. That's data plane. We're still on control plane. And of course, there's no BGP commands. Show BGP. Show BGP L2 EVPN. All right, so that's not configured. Show L2 summary. All right, that's what I wanted. This is what I wanted. We're idle. So can I even ping it? Ping 10.1 255.101 source 10.1 255.2. I can ping it, so I've got IP connectivity. So why is it idle? Do I need to activate? So I've got BGP configured, OSPF configured. Oh, my neighbor statement's wrong. Nope, never mind. Sorry. Yeah, that's okay. Configuring VXLAN. I don't like the way they do the ordering on this. configuring IBGP for EVPN for the spine. So it's on the spine. Next, hop on change. We might have to do that. Oh yeah, we want send community extended. I'll have to set up fabric forwarding at some point. That's a catalyst and a leaf. There's any configs in here. Just looking for any kind of packet coders. To the overlay. All right. So it looks like they're doing the same thing here. Unnumbered, okay. PIM. I'm not gonna do multicast in the underlay. All right, maybe we need to do this. So interface NVE1. Can't tell if this is what they consider the data plane or control plane. So no shut. Host reachability. Protocol is BGP. Source interface, back 0. Still idle. MPBGP, EVPN. Feature fabric forwarding. See, I like the way that this one's written. This one's make much more sense than they were doing. Address family. Do we need that? Routine route target all. Template peer. We're not doing route reflector. Leafs. Show IP BGP neighbors. 25101. No outgoing interface. Did I configure? Yeah, I do. Specified an outgoing interface of loopback 0. So what? Let's do log neighbor changes. So make sure I got the features right. Let's copy and paste all this. So I didn't have interface VLAN, but I don't think that's preventing this from happening. Unless... Oh yeah, so 10, 255, 1. 1, 2, was it 10, 2? I already forget. Show IP interface brief. 10, 1. BGP state idle, no outgoing interface. Is not configured for... Oh, it's not configured for IPv4 unicast. So maybe that's... Maybe I need address router BGP 65102. Address family IPv4 unicast. Configured for it. This is interesting. It's one of those weird things about weird quirks of these operating systems. (101) uses a template. I'm not using the templates. Maybe I should. Address family IPv4 unicast. Send community extended. Still says no outgoing interface. Don't know what any of this stuff does. That's where it gets really tricky, because if you don't know what this stuff does, then it gets it gets a little weird. What is it? Soft reconfiguration inbound. No idea what that command does. I'll look it up later. All right, what is it? Okay, we got... Oh, you didn't set a router ID. You should set a router ID. IPv4 unicast, remote AS, update source loopback 0, address family IPv4 unicast, send community extended. And once both send community, there's no like activate command. Let's look at this one. See what this comes up with. Oh, TTL. That's I was just talking about that earlier and I totally forgot about it. Okay, so neighbor 10.1.25.102 BGP multi-op 3. Still says no outgoing interface. but maybe that's established. Doesn't actually say established. Is that established? Check the spines. See what the spines say. Show BGP EVPN summary. Huh, it's established. Okay, so so it looks like we're exchanging. We at least have EVPN going. So now the tricky part is configuring the EVPN services. So I'll do it first on, because I know how to do it on Leaf 1, because that's containerized EOS. So we're just gonna do VLAN 10, just one VLAN. We're gonna stretch that out. So we'll configure the local. It all starts. Yeah, this out of order stuff is really throwing me for a loop because I've got a special way that I do it. I mean, it's not special, but I've got a way that I do it. And the other vendors, their guides generally don't follow that. And of course, what they're doing probably makes sense to them, but I really like this way because it's very regimented. So now we're doing the EVPN services. And in any EVPN VXLAN setup, it starts with the VLANs. So we're going to create a local VLAN. We're going to create local VLAN 10. And so that'll be just VLAN 10 in the VLAN database. That was all I needed to do. I'm not going to worry about IRB, integrated routing and bridging. I'm just going to stretch a VNI. So for the configuration, that's it locally. Then we need to attach that to an L2 VNI, virtual network identifier, or VXLAN network identifier. And so we do that in the interface VXLAN 1. Update, whatever the commands. VXLAN source interface will be loopback 0. I normally do loopback 1, but I wonder if that's going to be too complicated. So I'm just going to use loopback 0. We'll see what that. I can change it later. So VXLAN VLAN 10 VNI 10,010. So I try to use VNIs that are IDs that are above 4,000, just so I know that they're not VLANs. So that's it there. And that's the data plane. So I'm not going to configure IRB yet. I will if I can get all this working. And then in BGP, so router BGP, it'll be VLAN 10. So this is a MAC VRF. So what'll happen in EVPN is we learn a MAC address in the local VLAN, and that will generate a type 2 route. So we need to be able to generate that route. And configuring VLAN 10 is how we do that. So we're going to configure a route distinguisher. We'll do RD auto. Route distinguishers are needed to keep routes unique. Not only unique in terms of like addresses, because we can have overlapping addresses in one VRF or another VRF, but also a unique source. So we need to know if the route came from Leaf 1 or Leaf 2. So there needs to be something that we can distinguish these routes, and that's why it's called a route distinguisher. Next up, we're going to do a route target. And we're going to do import both. We'll do 10,010 or 10,010. We'll just do 1010. We use the VLAN ID. And then redistribute learned, which basically means that if we learn a MAC address, we're going to create a EVPN type 2 route. It's just going to have the MAC address in it. And we're going to put a route target on that route of 1010. So the other devices, the Cisco and the Juniper, we're going to want to import those routes into local VLAN 10 that have the route target of 1010. So that's how, when we distribute these EVPN routes, that's how we do it. And I'm going to do a test here. Host 1. connected leaf 1. We'll do Ethernet interface Ethernet 1. No switch port. IP address 10.1.10.11. And then on leaf 1, I'm going to do interface show LDP neighbor. Host 1's going to go Ethernet 3. Interface Ethernet 3. Switch port mode access. Switch port access VLAN 10. Show MAC address table VLAN 10. So what I'm doing here is I'm setting up so that MAC address gets learned on VLAN 10. We're going to see if we trigger that EVPN route, and then we'll see if it makes it to the spines. And then we'll see if the route makes it to the other devices. So even though they're not configured for anything, they should at least get the EVPN route, even though they don't do anything with it. I don't know what this stuff is up here. All right, let's see. Ping 10.1.10.1. So they're going to ping back, but it should generate a MAC learning event. So now we've learned the MAC address. So that's the MAC address there. Maybe, you know what? I'm going to do this. I'm going to do MAC address or MAC address. We'll do 000000000001. So what I want to do is all right. So that'll be our, that MAC address is going to be a lot easier to learn. This will time out eventually, but this will be good. I'm going to set a constant ping count. Ping count. Can I do a count? Repeat. 5,000. Interval 10. So I just need something to keep triggering that MAC learning event. So we've learned a MAC address on the local VLAN. Did that generate a type 2 route? We can do show BGP EVPN route type MAC IP. And we did. We generated that route. This is the old MAC address. This is the new MAC address. So let's go to the spines. Show BGP EVPN route type MAC IP, and they received the route. Now, how do I find out if the other devices did? Because I don't know how to check a Cisco. You see some messages here. I don't know. We haven't received any prefixes. Show BGP L2 EVPN route. EVPN. No. See if that verification. Looking for the verification. How do I see? All right, so do I see that? If I know the VNID, 10,010, we didn't get the route. All right, what about leaf 3? Show EVPN. Database. MAC table. Neighbor. Show BGP neighbor. So it shows we're established. Groups 1, peers 2, down peers. I got a warning about BGP licensing missing, but it still works. Some of the other ones didn't. So let's do Juniper show type 2 routes. Show route advertising protocol BGP. One 255.101. Didn't get any routes. So we should have propagated them because they're different. They're not accepting them. Because even if they're not doing anything with them, they should still receive the route. Maybe. All right, let's go back to Cisco, do them one at a time. So if you're just joining us, I'm trying to build a Franken-Fabric. This has been an interesting exercise. So what I did is host 1 is connected to leaf 1, and leaf 1 has learned the MAC address, and it's generated a type 2 route. So right now we're just concerned about the control plane. The route has made it to the spines, and the spines are either not sending them to the leafs or the leafs aren't accepting them. And they don't have to accept the route, or they don't have to do anything with the route, but they should at least still see them. Because the spines see them, and it's eBGP, so it should propagate. So I'm missing something on the leafs to where it's not taking it. So show BGP EVPN summary. So I'm a leaf 1. I haven't accepted any routes from the spines. So neighbor. VNI 2010. So, like, that's the route. So I've got a type 3 route as well. So that's a type 3 route and a type 2 route. IMET is the inclusive multicast Ethernet tag. I think that's what it is. So it's got to the spines, and I'm just trying to get the leafs to take them. So I'm not seeing anything with that VNI. I mean, it looks like I'm established. I just haven't accepted any prefix. It says here state and prefix received 0. So it's not accepting any of the prefixes. I'm not sure why. So let's go back to that wonderful blog post. So we're not doing PEM. Underlay. Yeah, so we're not doing that. Did I? Don't need these for now. Show interface. NVE1. It's up. Hardware is NVE MTU 9216. Probably want to trim that down a little bit. Show run interface NVE1. So no shutdown, host reachability protocol, source interface loopback 0. So that's good. And then here are the spines. We don't care about that. We care about the leaves. So we got log neighbor changes. I put a router ID, IPv4 unicast. That was weird. I didn't think I'd need to configure IPv4 unicast, but I did. Check something here. And then they're doing a template here. I don't need to do the template. I did need to do eBGP multi-hop, soft configured inbound, send community. Oh, maybe that's it. Because I'm just doing send community extended. So neighbor 10.1.255.102, address family L2 EVPN. Send community. It still hasn't received any prefixes. So we have our remote AS is 65001. So that's correct. Otherwise it wouldn't establish. Update source loopback 0. Update source loopback 0 for the neighbors. We got eBGP multi-hop. We got address family IPv4 unicast. We're doing extended and soft reconfiguration inbound. And then send community, send community. So that looks good. So show IPBGP neighbors. 10.1.255.101. Advertise receive. So that verification worked. Show BGP EVPN L2 EVPN summary. State 0. Capable appears to oh, did I not do send? You know what? I don't think I did. Wasn't even son of a. I'm not propagating the type 2 routes. That's why. I think that's what it is. So let's go to leaf 1 first. All right. No, I am. I'm sending send committee extended. Yeah, the routes are the routes are definitely there. But the spines, maybe I didn't do that on the spines. Nope, I did do send community. Peer group. Update source. Yep. It's neighbor state BGP NXOS. Can't tell if that that output is different because it's a different version. All right, I'm going to configure a local VLAN on here and see what happens. So VLAN 10. All right, so that's what we're doing there. We're not doing... We're just doing L2 bridging. Okay, so we set VN segment is 10,010. The VLANs in BGP or EVPN VXLAN, the VLANs don't have to be identical, but the VNIs do if you want to have a layer 2 stretch between them. But for simplicity's sake and for sanity's sake, we're going to configure the same VLAN everywhere. So oddly enough, that limits us to 4,000 VLANs in an EVPN fabric, even though that VXLAN is supposed to give us 16 million. It doesn't really work out that way in most cases. So we're not going to configure interface VLAN and then interface NVE1. Give me that warning. I already configured that. Run interface NVE1. Yeah, it did. Member VNI 10,010. Ingress replication. Protocol BGP. EVPN, VNI 10,010, L2, RD auto, route target, import 1010, export 1010. I'll do the same thing. I will put a host onto so leaf 2. Should be connected to leaf 2. Up, yeah, so we'll do that. So interface E1, no switch port, IP address 10.1.10.12, MAC address, all right, won't ping. But it'll keep the MAC address in the table. That's what we need. Show MAC address table. VLAN 10. Yep. Did I just set it for 2? Or 1? No, I did it for 2. How? Wait a minute. We learned that MAC address. How in the heck? It worked. Holy shit. I was not expecting that. It's not behaving the way that... this is one of the challenges of doing multiple vendor fabrics is you really got to do your homework beforehand. I mean, not that you don't have to do your homework beforehand for EVPN, but you've got to have a lot of this if you're going to build a multi-vendor fabric. So it learned the MAC address and it imported it and it put it into the forwarding table. So that's good. And interface, show LDP neighbors. Ethernet 3. 1.3. No shut. That's another weird thing. NXOS virtual 9kV defaults to shutdown on every interface. EOS doesn't. It's a little bit of a fun thing. Switchport mode access, switchport access, VLAN 10. I should be able to ping across now. Can I do that? Can I ping 11? No, that was a little too much to hope for. Oh, because it hasn't learned it. Show VLAN. Active on 1.3. Host 2 is on 1.3 on VLAN 10. Ethernet 1, 1.3. Holy shit, it worked. Okay, well, that was more than I was expecting from this. So, I pinged across the fabric. Fascinating. Let's see what we see here. I thought it was going to take a lot more. All right, so look at that. So now we've got the routes. MAC IP routes here. Why am I getting two of these? Yeah, I'm getting the routes. I'm getting the IMET routes. It's doubling up on the routes, though. That's kind of weird. Oh, that's why. It's getting it from both spines. I'm on leaf 1. So we're getting the routes back and forth. We get the data plane. We get the control plane. And it's working. So that's fantastic. Do I dare do I dare go for another one? Do I dare see if I can get it to work in Juniper? So let's do that. So thanks to Packet Coders, that was for Rick Donato. A very good guide. I really like the way he wrote his guide, because that was much closer to the way I do it instead of the way that it's on the Cisco site. All right, so let's see if I can do getting started. Oh, I think I was reading this guy, Simon Bingham. So Simon, I'm going to use your guide to hopefully get this going. So I think we've got the routes going. We've got EVPN going. Now we just need the VLANs and all the other stuff. So we have the set commands for those. Nope. where do we configure the VLANs? Okay, so we need to set some VLANs here. Leave 3. No. All right, config mode set. VLANs 10. VLAN ID 10. Oh, they give them names, I guess. ID 10. All right, so that's okay there. Set VLANs V10. VXLAN VNI 10,010. Set switch options VTEP source interface. It'll be loopback 0. Always with the dots after them. Set switch options route distinguisher. We'll do 10.1.255.3 colon 0. Doesn't really matter. Okay, set protocols. EVPN, VNI options, VNI 10,010, VRF target. So here we set the route target, target, 1010. I think that's right. Encapsulation, VXLAN. Extended VNI list 2010. It's weird seeing how the different vendors interpret all the EVPN standards. Juniper, you know, I've spent so much time with Cisco and EOS that you know, they're kind of my home. But good grief, Juniper, this is weird. This not seeing any making sense here. All right, then we do set interfaces, gigabit Ethernet 2, unit 0, family, Ethernet switching, VLAN members V10. Maybe? How do I know if to set that to an access port or a trunk port? Who knows? All right, let's go ahead and commit and quit. VRF target or VRF export must be configured. It gives a warning about VXLAN licenses, but I think that's okay. I think it still works because it warns about BGP too. All right, show config. I'll show config display set. Yeah, it doesn't have any of this stuff in there. So what was it? Switch options, VRF target or VRF export. I thought I configured VRF target. Oh, set routing options, router ID, 10.1.255.3. I think I already said that. Set protocols, EVPN, VNI options, VNI 10,010, VRF target. I think I thought I already set this. 10.10. Yeah, I did. VNI options, VNI 10,010. VRF target. 1010? Oh, target. Where X is the AS number, 650103. 10. Oh, I want to set that. I want to delete that. Set this. Nope, set. Edit VLANs 10. Okay, VNI options. Show. How do we see what was out of protocols? EVPN. Edit VLANs 10. Set VNI options. VNI 10,010. Oh, maybe I just needed to do that. Commit and quit. Show candidate. What am I even working with? Compare. Show. Compare. Display set. Protocols. And this is quite annoying. VRF target. Oh, I have to set, okay. Set switch options. Okay. Configure a different route distinguisher routing as the default switch as the assigned default. Route distinguisher for routing instance default switch. What was the command to see what? There we go. Yeah, I'm lost here. What does any of this stuff do? Route target. Well, we'll Google it because that's what we do as engineers is we Google it. I thought they were different. Well, I think that'll be enough for now. I'm going to go ahead and call it a stream here. So I'm kind of configure different route distinguisher for routing instance default switch. Show, compare, display set. Show display set. Oh, maybe it wanted something different here. Didn't like this. I don't know why I didn't like that. But it seems to have worked. Commit complete. And one, 0, 0. Okay, so that should be shut down. Ethernet 2. I should see on leaf 3. Show LDP neighbors. I see host 2. Show VLANs. VLAN V10 is on 02 and on VTEP. Show MAC address. MAC VRF. Forwarding. VLANs 10. Okay. MAC table. Well, looky here. Did we learn some stuff? I'm going to host 1. Yeah, we son of a gun. Kind of works. Kind of. So the EVPN route made it to leaf 3, and it looks like it got installed, but I don't think I have the interface configured right. So let's see, what's the equivalent of show MAC address table? Is there an equivalent command? Show Ethernet switching table brief. All right, so we learned it on that. So that looks good. How are we learning that one from there? So we learned the MAC address, and I think leaf 1, if we do show MAC address table. All right, we don't see 3. Let's trigger it again. I wonder if that's a problem. Let's go to the spine and see what we've learned. No, I'm getting routes. All right. I'm going to just go ahead and close this out. I'm close. I've got at least Arista and Cisco working together, and I think I've got just about set with Juniper. So I've got my Franken-Fabric is built, kind of, at least for layer 2. Maybe tomorrow will be layer 3, and we'll see what's going on. Man, I would not like to do this. This would be a lot of prep work if I were to run a fabric with multiple vendors on it. Eventually, I want to also do ESI. So do an ESI segment on leaf 2 and leaf 3. I have no idea how to configure that. So, but I know it's possible. A couple things I've learned. One, the only thing you can do this with, I think, on the Juniper side is VJunos switch. You can't do it with CRPD. Or at least I don't think you can. And there's weird licensing issues with them too. VJunos switch is the only one that just warns about a license. It doesn't like just stop working, as far as I can tell. But the other thing is both leaf 2 and leaf 3, they're not persistent because they're running as virtual machines inside of a container, inside of Container Lab. When I destroy this lab, it's going to not save anything, and I want to destroy the lab because it's consuming so much resources. My hypervisor, the fans are going crazy because of especially Junos vSwitch, eating up tons of CPU. Like, watch this. If I do Docker stats. Look at that. I mean, it's just chewing through the CPUs. And Nexus 9K is not doing much better. And then the containerized EOS is just taking up a pittance. So I don't want to keep this running. It's going to send up my power bill. So I have to destroy this, but I want to make sure that I copy the configs so that put this under here. Leaf 3 config. Config. Because it's just absolutely swamping the CPU. But it won't save. Normally, Junos is pretty nice in that it saves it automatically. So show config. Do display set. There's still some stuff I don't understand. Like how does some of this stuff translate into the RFC? So I'm at a loss. I mean, again, it might be a familiarity with Junos is pretty low, but it just seems to me that the Cisco and the EOS way makes a lot more sense in terms of how everything maps into the different aspects of the EVPN standard. But that just may be me not familiar with it. And Cisco's the same way, so I need to do a show run, copy the config. I could do automation to pull the config, but I'll just do a cut and paste for now. I learned a lot. I learned that I probably never want to run a fabric that is multiple vendors. Now, the other nodes, Spine 1, Spine 2, since they're EOS, they will save. Same thing for Leaf 1. I won't worry about the host because they're quick to config. All right. So that's it. I hope you enjoyed watching. I think there's a couple of you. And see you next time when we work on the Franken-Fabric.